So we're going to start in doing a regression. And so I'm going to start by clearing the calculator. So second and then the plus sign takes you into the memory menu. Number 7, these you don't arrow down like 7 times. Just hit the 7. It'll go to reset. I do a left arrow to get over to all, or you do 2 right arrows. And then hit enter. And then number 2 is reset, and it'll say resetting all, and away we go. So we're going to learn regression. So for those that are new to regressions, or those that are doing them all along, we're going to go to stat, and so hit the stat key. Number 1 is edit. If you didn't clear your calculator, if there's stuff in your lists, you can go second plus number 4, which is clear all lists, and then hit enter. So you want to start with clear lists or a cleared calculator. So in L1, we're going to put 1 through 12. 1 for January, 2 for February, 3. So these are average daily temperature for Calgary by month. So what we do is we take the average temperature for each day in the month. So let's say November. Take the average temperature for each day, and then we average those. Okay, so the temperature in November was negative 3.1. Okay, so on average, we take the average temperature every day, we average all those together, we'll get negative 3.1 degrees. So 5, 6, 7, 8, 9, October, 10, 11 for November, 12. When you're done all those, just right arrow get into L2. So in L2, we're going to put the temperature, so negative 8.9. So that's January, negative 6.1. February, negative 1.9, right? It starts to warm up in March. 4.6 for April. 9.8. 13.8. So still getting warmer. July, 16.2. So that's when we're going to max out our temperature, as in July, and then it's going to start to cool off again. So in August, not much cooler, 15.6 degrees. September, 10.8. October, 5.4. November, negative 3.1. And December, negative 7.4. Right, as we start to get colder. So the temperatures in Calgary vary. Right? They go up, hit a maximum, start to go down, hit a minimum, start heading back up, hit a maximum, minimum, and so on. Right? So this is very sinusoidal. It's that wave-like pattern that makes it sinusoidal. Show the scatter plot on your calculator. Okay, so we're going to set a window. And let's go from 0 to 13. That's not the 13. So go from 0 to 13. So 0 would basically be the December before. And 13 would be the next January. Right? So we're going a little bit beyond this window. If we start at 1, then the problem is we kind of cut things off. So if we go to 0, we'll be able to see the dot that's on 1 pretty closely. Scale can be 1, right? We're only covering 0 to 13. Our Y values, so we've got a minimum temperature, so negative 8.9 is the lowest. So let's say negative 10. That already is, that's good. And our highest is 16.2, so let's go to 20. So that's covering 30 degrees, right? From negative 10 to positive 20 is covering 30. Right? You do that max minus 10, right? 20 minus negative 10 is 20 plus 10 is 30. So we could go by 5s, we can go by 2s. And to go by 2s, that'll give us 15 ticks. Okay? I don't really worry about the scale. Like if it's not enough or it's too much, it's really not a big deal, right? But I mean, the scale on the x-axis is pretty good because that's going to be each month, right? We can look along to January, February, March, April, and so on. Now, if you want to look at the points, so far all we've done is we put in x values in L1, y values in L2. We're going to ask the calculator to graph these as an ordered pair. So we'll see the point 1, comma, negative 8.9. So 1, negative 8.9, and so on. to see those, we need to turn on our stat plot. So if you go second function y equals, right? So second just means the next key you hit is going to do the blue thing. So that's stat plot, and we're going to turn that on. So we're on plot 1. We're just going to hit enter. On, we're going to hit enter. And we never need to change anything else. Okay, so no matter what kind of regression we're doing or anything, that's good. And then we can hit graph. When we hit graph, we get what's called a scatter plot. And the scatter plot is just all the points that we put in. So one nice thing about scatter plot, it allows us, if I accidentally put positive 8.9 instead of negative 8.9, I'd have a point sitting up there. Right? So we can see these points it looks sinusoidal, right? It's got a wave pattern. We're only looking at 1 year, so we should be seeing one complete cycle, one period in a year. If we did 2, we wouldn't see anything else because all we've plotted is the points. Okay, so we enter in a calculator, show your scatter plot. There we go. Use the calculator to find the sinusoidal regression. So, okay, anytime we're going to run a regression, it works like this. We go to stat, we go over to calc, and there are all the regressions. Okay, so the ones that we have done to this point. Number 4, linear regression, right? Straight line. And they're always going to tell you what kind of regression to run. Okay, so if it's on the midterm, it's going to tell you run a cubic, run a quadratic, whatever. So we've done number 4, which is linear, straight line. Number 5 is quadratic, that's for parabolas. Number 6 is cubic, that would be for a cubic function. We don't do 7 or 8. 7 is quartic, that would be a 4th degree. I'm going to arrow down, so we'll just sort of keep going. We do ln reg, that's logarithmic regression. Okay, so that was the last test we did before the midterm was logarithmic. Number 10, or 0, is an exponential regression, so we've done those. We don't do a power regression, we don't do logistic, but sine reg. So we do sinusoidal, okay, and it's S-I-N-R-E-G. So you go stat, you go over to calc, you go to sine reg. Now, the fastest way to get there is just to actually do an up arrow. So an up arrow is the fastest way to the sine regression or the exponential. So I'll just show you. If we go stat, over to calc, since those are at the bottom, if I do an up arrow, it goes to the bottom of the list, and then I get there sine reg. Okay, then we hit enter. Now, either, depending on the calculator you have, you either see a screen that looks like this, or you just see sine reg and then an open parenthesis. If your screen looks like this, we'll take all of the defaults. So all we do is we just go down to store regression equation. So we're going to let the calculator do all the work. If you've got like an 83 plus or an 83, you're not even going to see all of that stuff, but these are the defaults. Okay, it's what the calculator uses. You don't give it anything. On this screen, we go to store regression equation, we want to put in y1. If you're just looking at sine reg in a bracket, now you want to put in y1. So to get y1, we go to the vars key. We go over to y vars. We hit enter on number 1, which is function, and then y1. So that works on every calculator, whether it's a TI-83 or an 84 plus silver color, whatever. Vars, over to y vars, enter on function, enter on y1. If you're just looking at the word sine reg and you've got y1, you hit enter. If you're looking at this, you hit enter to go to calculate, and then you hit enter again to run the regression, and it's going to give us the sinusoidal regression. So it gives us a sine equation. And we are going to round values to the nearest hundredth if necessary. So we're not going to copy this out. We're going to write the actual equation. So any equation, it's always going to be of the form y equals, right? So midline is y equals d. If it's linear, it will be like y equals 2x minus 5. So sinusoidal, 12.72. So this gives you the format A times sine, so 12.72 sine, bracket, B, so we'll go 0.51, because we're rounding, x, plus C, so C is negative, so we're just going to go minus 1.98. And then plus D, so plus 3.65. So we put our points. So we clear the calculator or you clear all the lists. You go second function calc, or sorry, you go stat, edit, that takes you into the list. You put your x values in list 1, you put your y values in list 2. To get the scatter plot, you go second function y equals, that takes you into the stat plot menu, and you turn on plot number 1. So later on, if you ever see error invalid dimension or error invalid dim, it means that your stat plot, your stat plot is still on, but you've cleared out your list. So it's got nothing to graph, right? Because you're basically saying, I want you to plot these points. And if you don't have any points in your list, it can't plot anything and it'll give you that error. If you're not sure how to get rid of that error, so the way to get rid of it would be to turn off your stat plot, go second function y equals, go from on to off, hit enter, and then you should be good to go. You can't remember that or whatever, just clear your calculator, right? Second plus 7, left arrow, enter 2, clear it, start over again, you'll be good to go. We ran the regression and we put this into y1. So if I go to y equals, on y1, this equation with all of its decimals is sitting there and we can use it. So if now I hit graph, well, wait a sec. We're not graphing yet. Use the equation to find the max and min temperatures rounded to the nearest 100. Okay, so how do we get the maximum? We've got this equation sitting there. How do we get the maximum? A plus D. Yeah, so D plus A, or A plus D. So that's A, that's B, that's C, that's D. So the max is equal to D plus A, which will be 3.65 plus 12.72, which will be 7, 3, carries 1, 6. So 16.37. Okay. Now think about that. What is it? This is temperatures, right? So it means that the average maximum daily temperature is 16.37 degrees. Okay. Now remember, it's an average temperature for the day. So we know we get days that are warm. It could be 30 degrees in that. But remember, when it's 30 degrees in the afternoon, when you woke up that morning, maybe it was 12 degrees. We're just saying on average over the whole month. Minimum is D minus A. Yes, remember, D is the middle, the median, right? A is the variance from the middle. How far up do we go? Well, from this 3 points. What? Why would you live here? It's like average temperature in the year. The middle temperature is 3.65 degrees. The middle. So half the year it's warmer than 3.65 degrees, and half the year it's colder than 3.65 degrees. Well, we're a hardy bunch, I guess. Gonna live in this cold climate. So 3.65 minus 12.72, which, if I can do the math, is 9.07. And somebody might want to check that. Negative, right? Subtract it all. Yeah. Got the minimum above the middle. So the minimum, remember this is for a month, right? Not for a day. So we're not modeling temperature by day, where the period would be 365. Right? We've got a period of like 12, because our x value is the month number. See, it says up here, x, which goes into L1 is the month number, and y, which goes into L2 is the daily average temperature. Determine, which means show your work, the period of the function. Okay, so there's one formula we get on the formula sheet, which is period is equal to 2 pi divided by b. So for us, period is going to be 2 pi divided by 0.51. And I'm stringing this along from left to right because there's not enough room to write up and down. And Go to our calculator. So we'll just quit out of there. Okay, so 2 pi divided by 0.51. And that's 12.3. So 12.3 what? Months. But now that you mentioned degrees, the min and the max will be in degrees Celsius. So anything to do with D and A is up-down, which is temperatures. Anything to do with B or C is left-right, which is months. Okay, so when we get the period, because we use the B value, that's months, right? The period is 12.3 months. Now, that matches up with what we think it should be, right? Because it should be 1 year. So this says the period is like just a little bit more than a year. Based on the model, remember this is just a model. And on here, because we are finding min and max temperatures, we should put units with those. So 16.37 degrees Celsius, negative 9.07 degrees Celsius. Figure out the start point and explain what that means in the context of this question. Okay, so I will give you, so I'm not going to give you a formula sheet on this test. I'm going to put the formula at the top of the test. Okay, because there's only two. Y is equal to a sine bx plus c plus d, and period is 2 pi over b. So no point, we don't need to hand out a bunch of formula sheets. And I also want to give you the start point. So that's the formula for the start point. Negative c over b, comma, d. So determine the start point. Well, okay, we know c, right? We know a, b, c, and d. So all we're doing is substituting into this. So negative c, so the negative of negative 1.98 divided by 0.51, and d is 3.65. All right, let's work that out. So negative is positive. You don't have to put two negatives into your calculator, right? You just say, I'm doing negative of a negative, it's just going to be a positive. So all I care about is, what's 1.98? 1.98 divided by 0.51. And it works out to 3.88, 3.88, comma, 3.65. We didn't just throw in some numbers, right? Hey, here's a table of numbers, run a sign regression on them. There's a context here. This is a table of values of each month and then the average temperature. When there's a context, so this says explain what this means in the context of the question. And on the diploma, you're likely to get something where you have to explain something. It's the whole idea of you have two written response questions, right, worth 7 marks each. So usually the first question or first bullet is just, maybe it would be asking you what the period is. So in this case, you're just going to go with 2 pi divided by d, and it's 12.3 months, and that's what they're looking for. So a very easy calculation, or maybe just pulling one of the numbers out of the equation and explaining a little something about it. That's worth 1 mark. And then you have 3 parts, each worth 2 marks. So something like this. So what does this start point mean? Well, we know that the start point is when you first reach the midline. So for us, so as a matter of fact, let's draw this function down. So before we answer that, let's just go draw the function. So here's our midline, right? This is d is equal to 3.65. We go as low as, what do we say? So about negative 10, it was negative 9. So we'll go from negative 10, right? And we'll go up to 20. So let's go as high as 20. Take my negative 10 and make it like half of that. So there's negative 10 and 20. The start point is 3.88. So, it's a year. Sinusoidal functions kind of work on being split into 4 parts. So let's say we do our scale every 3 months. So 3, 6, 9, 12. So we know, wait, that's 3.88. So 3, 6, 4. So the start point is when you reach the midline and the graph is going up. And that happens at 3.88. Okay, and then since period is 12 months, right, we're going to hit the maximum in 3 months. So that's, again, just going to be, since these are each 3 months, it's just going to be about the same place over. We'll hit the max. In 3 months again, so again, about here, we're going to be back to the minimum. And then in another 3 months, or sorry, back to the middle, or 3.65. In another 3 months around here, we'll hit the minimum. And then 3 months ago, we would have hit a minimum. Right? So the period is about 12 months. You split that into 4 parts. So for a sinusoidal function, those 4 parts are from the minimum to the midline, from the midline up to the maximum, from the maximum back to the midline, from the midline down to the minimum, and keep going. From the minimum to the midline, to the max, back to the middle, to the bottom, to the middle, to the top, to the bottom. And each one of those happens in 1/4 of the period. Right? So a sine function has 4 parts. So if we graph this over 1 year, it's going to look something like that. So here's a question, because we haven't really answered this context, right? So where are we in the year if we're 3.88 months? So where in the year would we be? Because the x value is in months. So March, and then if we wanted to, we'd say, well, there's like 30 days times 0.88, it'd be like about 24. So March, but what happens around March 24? Yeah, spring, right? Spring equinox. Spring is when we hit the median temperature, right? The middle, right? Middle of the year. Summer, when we're going to hit the high end 3 months later, right? So we have 4 seasons, each one is 3 months. So spring is when we first hit the median temperature for the year. Summer, we hit the max. Fall, so in September 21st-ish, whatever, that's when we're back to the middle again. Okay, so we hit, so a couple months ago, a month and a couple weeks ago, we reached that median temperature, right? Average daily temperature about 3.65. Now it's kind of warm out now, but we reached that median temperature again, and now things are getting colder, and will get colder until December 21st, right, which is winter. Okay, the start of, there's like, what are the seasons? It's like celestial and meteorological. So the celestial seasons are based upon our position with the sun, blah, 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 and the equinox and stuff like that. And meteorological is, summer is June, July, August. Fall is September, October, November. Winter is December, January, February. Spring is March, April, May. Right? That's more of a, based on the calendar, based on our perception of the seasons, June, July, August is summer, not, June 21st to September or whatever, right? September, October, November is when we're hitting fall. So end of this month, really the end of fall. Okay, and winter then is December, January, February. That's meteorological. That matches up with our perception of what's going on outside. Okay, so the question here is, or the start point, what does it mean? So the temperature first reaches the median temperature, and is going up, at 3.88 months, okay, which we'll call late March, right, or spring. Right. Yeah. Warning. Come on, plug in. Saved. Charging. We're good. So pay attention, right? When you're graphing these. Now we haven't even looked at the regression, right? So we saw the scatter plot on the calculator. We saw what it should look like. And our scatter plot does kind of look like that. And if we go back to the calculator, which has turned itself off, and we hit graph, we see our scatter plot. We put the equation into y1, and now it's drawing the curve. So does that look like a pretty good fit? Yeah, right? I mean, it's like almost through, it's through the middle of this point, and definitely right through the middle of that. It's at least touching all the points, so it's a good regression equation, right? Now keep in mind, what it is, that's a model for the average daily temperature per month throughout the year. So you give it a month number, it will tell you the average daily temperature during that month is going to be blah. Now, it's not like hours of daylight or time of sunrise or sunset, right? Those are fixed. We know what those, we can ask in 200 years, what is the time of sunrise on November 4th, or 200 years, 2220, right? And we can get that. That's fixed. Temperatures, we could say, hey, on average, it should be this, right? But we know temperatures vary. I mean, you know, it's November 4th, it's 13 degrees out right now. That doesn't happen a whole lot. So we know the temperatures will vary, right? Hours of sun or time of sunrise or time of sunset, those are fixed. They can be found exactly. All right, so we've got this really nice fit that matches with the diagram we drew here. That matches with, you know, if we're going to say stuff. If I go to y equals, I always like to graph the middle, so 3.65. Right? If I graph that, if we do an intersect here, we'll see it's at 3.88. Second calc. Run an intersection on this. Move to about 0.23. All right, so 3.91. Can't remember, why are we off? Well, we were using 2 decimal places. It's using the exact value, right? So generally, if you want answers out of the calculator, use the regression equation that the calculator gave you. Just use the calculator, right? Because it'll have all 8, 10, 12, whatever decimal places. If we're using a rounded value, as we were asked to here, then our values are going to be off by a little bit. So we had 3.88. This has 3.92. We can ask questions like, all right, so what do I expect the average temperature in the middle of November, right? So middle of November is a time, it's 11.5 months. So at 11.5, we can expect the average daily temperature to be about minus 4.5 degrees. Okay, minus 4.5 degrees. We can also ask questions about, so the next question, compare this graph. Yeah, so we graphed it on the calculator. We looked at the one that we drew above, matches up. So we can see that experts recommend changing to summer tires when the daily average temperature is 7 degrees or higher, and recommend changing to winter tires when the daily average temperature is below 7 degrees. Using the graph on your calculator, determine when you should be changing your tires. Question of interest to all of us, well, anybody who drives, right, is when should I change over? And the reason is, if you have summer tires, like just pure summer tires, they got a very soft rubber compound. At 7 degrees, that rubber starts to harden up, and you get less grip on the road. And if it gets down below freezing, you have very little grip, and when you start adding ice and snow into that, you have no grip with those tires. So you don't want to be riding around on summer tires when it starts to get colder out. So we're going to go to y equals. Instead of graphing the middle, we'll graph 7 degrees. So to clear that out, we'll throw in 7 degrees. And we'll hit graph. So over here, we'll go look at what we got. We got that. That's y1. So y1 is the equation, which was what? 12.72 sine. 12.72 sine 0.51 x minus 1.98 plus 3.65. Got y2 here, right? y2 is equal to 7. So as it warms up, right? So as the temperatures start climbing and it warms up and it hits 7 degrees, right here, this is when we can change to our summer types. Change the summer types. So when is that? Well, second calc. So we need the intersection. All right. So when we do an intersect, we just move down to about the point of intersection, hit enter 3 times. So 4.44 months. All right. So January is month 1. February is month 2. Month 3. March, April. So it's April. And it's 0.44 of the way through April. So we can get out of the graph, second quit. I can take x, subtract off the 4. We're just doing it to the decimal part, right? So April has 30 days, so multiply that by 30 times 30, right? And we got about April 13th. So minus 4, 0.44 months. So April 13th. Okay, it's Calgary, that's way too early. I like Victoria Day, but that's what the model is telling, right? That the temperature should be above. Now we all live here long enough to know we're going to get a dump of snow in April or May. You do not want your summer tires on for that, so you're going to wait. And when does the model say, oops, I don't want the table, but I got the table. What does the model say? So when we hit here, right, this is when we will change to our winter tires. Okay, so because at that point the temperature is going to be back at 7 degrees Celsius, and we know from then on it's going to be below 7 average temperature. Second calc, intersect. Now it's faster to move along the red line because it's straight. So right now it's on the blue line. At the very top you see the equation is in blue. That's my sinusoidal. If I use the down arrow, we'll go to the equation y equals 7. And then if I trace along, it's just going to move on the straight line, right? So we'll get there. I mean, you're not going to save a whole bunch of time, but. And you can just hold yours down. You don't have to do this. Okay, and we go to about the point of intersection, and the calculator's asking us, what's your first graph? So we're going to say it's the line, y equals 7. What's your second graph? We're going to say it's the curve. And where's the intersection? And we already moved there, so we're there. And it says 9.59. 9.59. So 9 is September. 0.59 is going to be a little halfway through September. Right? We can figure out what day. So if we get out of this, take the x value. So when you hit x, that's the number that when you run a regression, x is the x and y is the y value, which for us would be a 7. Take that number, subtract 9, because I just want the decimal part of it. Multiply that by 30, because 30 days past September, April, June, and November, and all the rest have 31, except February, just 28, or this year 29, 4 years 21, leap year. So about September 17, 18. Which in Calgary is not a bad day to switch, because we know, and this year didn't happen, but often we'll get hit with a dump of snow in September, so that's not necessarily a bad day to switch over. Kind of middle of September. This year you could have let it go till like Thanksgiving. Weather was nice. Temperatures were warm. And as long as you're not doing if you're doing a lot of driving in the morning, even in September, October, even when it was nice, it was still fairly cool in the morning. So your tires would not have the same grip. All right, any questions about this? So to review, just run through this, what did we do? So we were given a table of values which describe a sinusoidal, something which varies sinusoidally, right? It's got that wave-like pattern, so temperature. We had this, by the way, this is real data for Calgary over the last 30 or 50 years or something. We put it in the calculator, we drew a scatter plot, looked at it and said, yeah, it looks sinusoidal, right? It looks like a wave. We ran a sine regression. Now you'll always be told what type of regression to run. So you don't have to worry. Diploma exam, the in-class final, whatever, to say run a cubic regression, run a sinusoidal regression. Now, it might show you points that are in a sinusoidal and ask you what type of regression that you should run. In which case you look at it. So if it looks like a parabola, you would say, okay, run a quadratic. If it looks like a cubic, you'd say run a cubic. If it looks sinusoidal, you'd say run a sinusoidal. So they might show you a curve and say, what type of curve is this? Okay, that's a possibility. But if you're running a regression, they're going to tell you what type to run. So we know, put the x values in L1, y values in L2, run that stat calc, choose the regression that you're doing, put it into y1, because you're going to use that. Now, it's sinusoidal, so we know how to analyze the sinusoidal function, right? D is the midline, that's the median. In this context, it says the average temperature in Calgary in the year, during the year, is 3.65 degrees Celsius. Half the year, it's going to be above that, reaching a maximum of, take D plus A, from the middle to the max, varies by the amplitude, a minimum of D minus A. The period is 2 pi divided by B. The period is in months, so whatever unit, right? The max and min are in degrees Celsius. If it's tides, max and min are a Ferris wheel. You've got height in meters versus time in minutes or time in seconds or whatever. The start point, so that negative C over B is when we first reach the median value and the curve is rising. The curve is going up. So if you've got a description of it and you've sketched it out, then keep in mind where you are, right? If we were asked, remember we did one with tides the first time after 6 a.m. that the water reached this particular height, we need to be aware of where are we on the curve. We took all that information and we said, well, we got a min, we got a max, we've got our midline. We can pretty much sketch it out. We know the period, and we know the period is split into 4 parts. So we can draw our own sketch. We then match that sketch up with the graph on the calculator and say, yeah, it's good. And then we answered a couple of questions. So we did a couple of things. We said, when did the temperature first reach the middle temperature? Right? And we had calculated that using our numbers rounded to 2 decimals to 3.88. And when we did it on the calculator, we got 3.91 because it's using the full values that it has inside of it. And then we asked the question about if the y value is 7, if the temperature is 7, when will you first reach that temperature? So for our purposes, that was when can I switch from my winter tires to my summer tires? And when do we get back to that temperature of 7 degrees again? Or when should I switch over back to my winter tires? Okay, so that's running a sinusoidal regression, so modeling and then answering questions using that equation. And we're done.